In this video, I'm going to show you how to test if a set of points is a linear relationship. And I'm going to show you three ways to do this. The first way I'm going to show you is by using the definition of linear. Uh, Linear relationships are defined as equal differences over equal intervals. And all that means is that if you were given an XY table like this or a set of points, then you need to make sure that the X always increases by the same amount and the Y also increases by the same amount. So this one goes down 7 and this one goes down 7. These numbers don't need to be the same as each other, but these numbers always need to be increasing by 3 and these numbers need to be always decreasing by 7. So this only works if your table has a pattern to it. You can see that all my X values are increasing by 3, and the Y values are always decreasing by 7. So that definition of linear only works when the table or the set of points you have has a pattern to it. If it doesn't have a pattern to it, then you have to use the second way, which is to do it algebraically. Remember, the slope formula is to find this change in y over the change in x. And all you're going to do is just make sure every point in this table has the same slope, every 2 points that you pick, basically. So why don't we find the slope of these two, then find the slope of these two, then find the slope of these two, then find the slope of these two. You don't have to do a million of them, but you should check a few of them, make sure that it always has a constant slope. If a set of points or a table of values always has a constant slope, then that means that it is linear. So if I look at these 2 points, then my change in y is up 1, and my change in x is up 2. So right here, this one is 1/2. For this one, my change in y is up 6, and my change in x is up 12, so that's 6 over 12, which reduces to 1/2. Now I'm going to use these two middle ones. The change in y is up 2, and my change in x is up 4. 2 over 4 reduces to 1/2. And then I'm going to use this one. My change in y from -6 to 3 is up 9, and my change in y from 2 to 20 is up 18. 9 over 18 reduces to 1/2. So another way to check to see if a relationship is linear is just by literally doing slope a bunch of times. I had 4 points here, so I did it, and I made sure that every point matched up with every other possible point to see if slope is always the same. When I say I used every possible combination, that's not true. I used 4 possible combinations. There's a couple more I didn't do. But if it's linear, then any 2 points I pick should have the same slope. So I just did a bunch of slopes to make sure. Now the third way to check to see if a relationship is linear is by doing it graphically. All right, so if I have an equation here, if I have some points that I put on this graph, let me get my points here. So this one would be 2, 2, and this one is 3, 5, and this one is 0, -4, and this one is -2, -10. So this relationship, which is off screen here, just gave me 4 points, and it wants to know if this relationship is linear. Well, to see if it's linear, I could literally just plot all the points and see if it's linear. This looks linear, right? It looks like all of the points line up nicely to make a line. And if I really want to check it, I can find the slope between 2 of them and then calculate the y-intercept and make sure that that line that I find, the equation I find for all these points actually is going to hit all those points. So let me do that really quickly. Let me find the slope of this. The change in y is 3, and the change in x is 1. So my equation is y equals 3x. And my y-intercept is right here, 0, -4, so -4. Hey, look at that. These points hit all four. These points lie, all four of them lie on the line. So that means that this relationship is also linear. So to recap the three ways, look for patterns in the table and make sure that the differences in the y's and the differences in the x's are always the same. They're always equal. The second way to do it is to just do slope a bunch of times and make sure that the slope is always the same, because linear relationships have a constant slope, a constant rate of change. And the third way to do it is to put all the points on a graph and make sure that they do indeed line up. And you can find the equation just to confirm that.